All right, so page 39, we're going to look at piecewise functions. So piecewise functions are functions. That does not even look like an F. That says functions, but my handwriting's bad. Functions determined by two or more subfunctions. So I was really trying to decide how exactly I wanted to say this. I'm not sure subfunctions is really even a thing, but I like the way that that sounds better, because I don't want to just say two or more functions, and we could talk about them as just being expressions, but they're kind of subfunctions of a big function. That makes sense to me. So there are functions determined by two or more subfunctions, each with its own domain. So we have already looked at one when we wrote the signum function as a piecewise function. It can be written two different ways. So regardless of the level of Algebra 2 you were in, you did look at piecewise functions. You may not have graphed them if you were in on level, but you should have looked at them and evaluated some numbers, kind of like what we're going to do right here, and maybe looked at domain and range. My bracket looks weird up here. I don't know why mine does and yours doesn't, but this one does. So I think yours looks fine on your paper. So what we're going to do, here's a piecewise function. And so this is what we mean by, this is the function f of x. It's determined by three little subfunctions, and each one has its own domain. These are functions, which means they will pass the vertical line test, so there should not be any overlap there. But we're going to evaluate these, well, this one in particular, at three different points. So f of negative 5. When I want to find f of negative 5, do I substitute negative 5 into all three pieces? No. How do I know which one I substituted into? What do I need? What do I look at to determine which one? The domain. Okay, maybe I should ask it that way. If it's negative 5 is only going to fit into one of these three domains since it's a function, right? So which one? The first one. Good. So that's the first one. Negative 5 is less than negative 3. So it's this part that I put it in here. So f of negative 5 is equal to 2 times the absolute value of negative 5 minus 5. So what's negative 5 minus 5? Negative 10. Absolute value is times 2 is 20. So f of negative 5 equals 20. That's simple. So then I need to find f of 2. Which part 1, 2, or 3 does that get put into? 2, because it's between negative 3 and 7. So that's going to equal negative 2 squared plus 4 times 2. So when I square that, does that become a positive 4 since I'm squaring it? No. Yeah, okay. This becomes a positive 4. I should have asked that better. This becomes a positive 4, but then it's actually negative because of that negative sign. So negative 4 plus 8. So f of 2 is 4. And make sure you're answering these as f of 2 equals 4 and not just 4, and that's it. All right, and so then 7, f of 7. Well, it has to be, there's a 7 here, but it's not included, right? So it goes in that last part. F of 7 is equal to the square root of 2 times 7 plus 6. So 2 times 7 is 14 plus 6 is 20. And then the square root of 20 is what? 2 square root of 5. Good. Simplifying square roots, definitely something we should all have experience with. You should have done it in geometry, no matter what level you were in, and algebra 2, no matter what level you were in. I'll give you the, rationalizing the denominator with the cube root like we did the other day. If you weren't in pre-AP algebra 2, you didn't see that, most likely. But pre-AP, definitely y'all should have done that. But simplifying square roots, that is something that you're all expected to be able to handle. So if that's a little foreign to you, I cannot stress Khan Academy enough. With that said, okay, so back to number 2. Then now I'm going to find g of negative 3. G of negative 3, which part do I put that in? The second one, right? Because negative 3 goes in here. So what's 8? then g of negative 8. Negative 8 would go into which part? The first one, because negative 8 is less than or equal to negative 4. So g of negative 8 is equal to 1/2 times negative 8 cubed plus 7. All right, so I'm going to give you a second. I want you to get to that. You can find g of negative 8 on your own. All right, raise your hand if the first thing you did was cube 8, or negative 8 rather. Okay, which looks like all of you. All right, I'm not saying you're wrong, right? But that's kind of a big number, right? Remember this whole let's think smarter, not harder. Nothing wrong with cubing 8 and taking half of it. I mean, that's kind of what it's telling you to do anyway. But isn't 1/2 times negative 8 cubed the same thing as 1/2 times negative 8 times negative 8 times negative 8? Right? And I wouldn't expect you necessarily to write it out, but that's the same thing, yes? So what I would do in this situation would be multiply these two together and get negative 4, multiply together and get 64. Now all I'm doing is multiplying 4 times 64. And when you multiply something by 4, you can double it and double it again. So 64 times 2 is 128. 128 times 2 is what? 256, and it's negative. Negative 256 plus 7. Okay, does that make sense to you? So again, learning how the numbers are put together and what this stuff is saying, that would be, you know, unless these were odd numbers, then that wouldn't have done me any good necessarily. But you know, just kind of helps you with not such the big numbers, because those are the types of things that when we end up then making a mistake on, not that we're stupid, but because we're human and we mess up on silly things, that I didn't even get my number to be that big, so I don't have to worry about it. All right, so g of negative 8 then is what? Negative 249. Good. We good? And then I saw somebody earlier today that's very capable of doing all of that in their head and like not writing anything down. I'm not capable of not writing anything down, but somebody else was doing that, and they didn't have the right answer in the end because they did try and just quickly do it in their head and made a mistake, because again, we're human. It's probably good for you to at least write some of the parts down so you don't get the numbers mixed up, but I didn't have to do all the huge multiplication. All right, then I need, okay, so this thing here, this is the greatest integer function, which we didn't do. We've changed it to signum a few times on these notes or on this assignment. Say it at the end. If it looks like the greatest integer, we're just changing these to absolute value. Okay? So that really means absolute. That's not what that little symbol means, but we're going to change it to that right now because I already had all these copies made. So g of 3.1 is equal to the absolute value of 3.1 minus 4. What's 3.1 minus 4? Negative 0.9. What's the absolute value of that then? 0.9. Everybody good? Any questions? All right. All right, so graphing. We're going to graph each function, then give the domain, range, and identify the location and type. I did realize yesterday, while I was sitting at my desk when Miss Williams was teaching, that these grids, well, the lines I can't see even when I'm right up here on these, but it was hard to see where she was putting some of those points because the grid was kind of small, so I'll make it a little bit bigger. Y'all need to tell me when things are hard to see. I didn't realize that. So we're going to graph this, and I've got 2 pieces to graph, and I need to know where that break is in my graph. So the best thing to do would be to start off by figuring out where those points are. So this function, or this part of the function, is only when x is less than 0. But I need to know where it stops, so I'm going to substitute in this 0. So when I substitute 0 in here, 0 plus 3 is 3, absolute value. Then minus 1 would give me what? 2. So when I go to 0, 2, am I going to put a closed circle or an open circle? Open circle, okay? So everything to the left of this over here would be that first function. And then I need to substitute 0 into this one so I can figure out where the second part starts. So 2 times 0 minus 5 is negative 5. So go to 0 and then 1, 2, 3, 4, 5. Okay. So I've got the end of the first graph, the start of the second one. Then I can go back and figure this out. What is this parent function called? Absolute value. All right. So you should know that your absolute value looks like this, right? And if you need to write out your transformations, you can still do that, obviously. If you need to put your anchor points on the graph, you can still do that. But we should get to a point where we don't have to necessarily put them all on there, okay? So I know that one of the anchor points for my absolute value is at 0, 0. So I can start there. Do I have any reflections with that one? No. Do I have any compressions or stretches? No. So it's only translation. So starting at 0, 0, horizontally I would do what? Left 3, and then down 1. So this is the new vertex of my absolute value. Now, because I didn't reflect it at all, if I know that this is the vertex, to get the right side of my V, do I even have to find any other points? Nope, I sure don't. So I've got this right here, once it decides to draw. There we go. So there's the right-hand side. So I do need to get the left-hand side. So negative 1, 1 is an anchor point. So I can take that point, translate to the left 3, and down 1. And I've got that one right there. And then negative 2, 2. So I can go to the left 3 and down 1. Did I really even need to do that second one? No, because this is like part of a line, so after I get 2 of them, that's all I really needed. For the curves, you do have to get those extra ones on there just so that you can get the shape, but since it's a line, they should line up just fine. So there's that absolute value when x is less than 0. Then the next part of the graph, what's that parent function? Linear, okay? So this is an easy line to graph in any situation. Y-intercept is negative 5. We already have that. Even if that wasn't the y-intercept, it really doesn't matter. It's a point on that line somewhere. And then I have the slope. What's the slope here? 2. So from this point, I can go up 2 and over 1. Do I need to do any other points? Nope, I sure don't. If you're still doing like 20 points to create a line, then you just need to stop. And there's that. And there is the graph of my piecewise function. Okay, everybody okay with that? All right, so then I have to find domain, range, continuity. So is my domain here all real numbers?
Yes.
Yes? Y'all agree with that? He was very adamant, yes. Okay. Negative infinity to infinity, good. Is my range all real numbers? No, where does the range start? Negative 5, and then where does it go to? Infinity. Do I include the negative 5? Yes, I do. Now, if this had been the included and this was open, so this was a closed circle and this was an open circle, then would I include 5? No. Okay. Do I have any discontinuities? Yes, kind. Jump. This is a jump discontinuity. X equals 0. Somebody asked a question in third period. It was a good question because this was something that was done wrong multiple times on the test. I said, well, what's removable then? Because I would have people tell me this is jump, but also try and do removable there because that's a hole. That's a hole there just because I couldn't be solid because of this, but this is a jump discontinuity. Removable discontinuity would just be a random point missing off of a line or off of a curve. Okay? Not on the end where it would be like a jump. Does that make sense to you? So just some random hole, which we'll get when we get to the more rational. Uh-huh. Okay. Yes. Okay. So you're saying that actually there's a couple. So this y value of 2 there's no y value of 2 right here, but there is one right here and there is one right here. And so that's why we don't stop on the range because, yeah, I have a little hole there, but 2 is still a y value that works in this graph, so it is still part of the range. Does that make sense? That's a good question, too. We all okay on that? Okay, good deal. All right, next picture. All righty. So I've got 2 pieces again. I'm going to substitute in this negative 3. So negative 4 minus a negative 3 is negative 1. So negative 3, negative 1. Open or closed? Closed. Good. Then I'm going to substitute the negative 3 into here. So negative 3 squared is 9 times negative 1/2 is negative 9/2, but to find it on here, to think of it as negative 4.5 or negative 4.5 is fine. So go to negative 3 and then negative 1, 2, 3, 4.5. Open or closed? Open. Okay. So on the left-hand side, that first part of that function, what's the parent function? It's linear. The y-intercept is negative 4, but I don't care because negative 4 isn't going to work for me here. Do I know the slope?
Yes.
Yes, what is it? Negative 1. So from this point, because I do know that this point is a point on that line, I can just count the slope, negative 1, and there's my other point right there. I can draw in my line. Then the other part, what's the parent function? It's a quadratic, okay? So it's a quadratic. That negative will reflect it in what? The x-axis, okay? So it's going to reflect in the x-axis, and then the 1/2 does what? Vertical compression. Okay. So I know that that's one of the points on my new parabola, but I'll start with my 0, 0, which is an anchor point. The negative does nothing. The 1/2 does nothing because I'm at 0, 0, and so I just stay there at 0, 0. Very unexciting. Then I can go to 1, 1, right? The negative is going to reflect it in the x-axis. That's a what kind of compression? Vertical. So I multiply what by 1/2? Y. So that becomes a negative 1/2 right there, and that's it. So I got a point right there. I have symmetry, so there's a point over here. Then I can go to 2, 4. I'm going to reflect it in the x-axis, so I end up right there. I vertically compress it by 1/2, so that 4 gets multiplied by 1/2, which makes it to 2, right? And then that's my point, and then I have another point right here. Okay. So then my parabola looks like this. Oh, sort of missed there. I can't see what I'm doing. There we go. Something like that. But better. Always better. It's easier for me to do on paper. So is my domain all real numbers? Yes. I'm going from negative infinity to infinity. My range, as I come up, this is going down to negative infinity. So I'm using all of these y's. The fact that there's a hole here is fine because this y gets taken care of there. Just keep on going up. So it's also negative infinity to infinity. Discontinuities? Yes. Yes. Jump at what? X negative 3. 3. Okay. Everybody good? Yes? All right. Let's look at the next one. So I substitute in that 1. So I'll get 4 over 1 plus 3, which is 4 over 4. So that means 1, 1 is a point. Then I substitute 1 into 2x minus 7. That's going to give me what? Negative 5. 1, 2, 3, 4, 5. And that's an open circle because it's not included. Everybody with me? Yes. Okay. So now I'm going to go back and do the left-hand side of my graph. So the parent function of that is called a what? Reciprocal, okay? And the reciprocal has some, characteristics that are very different from the other parent functions. What kind of characteristics are very different than the other ones? We've got asymptotes. You could do vertical and horizontal compressions and stretches. And there's 2 pieces, right? And it doesn't matter which one you reflect in. So all those things are important to remember. So the asymptotes are what we're going to look at first, because as we go to draw this on here, I got to get those on there too. So I'm going to, the asymptotes are affected not by the stretches and the compressions, but they're affected by the translations, right? So this gets translated where? Left 3. Does it get translated up and down at all? No. So my vertical asymptote gets translated left 3. So I end up right here. There's no vertical translation at all. So the one that's on the x-axis stays, but this function only happens until you get to 1. So the asymptote doesn't even go all the way across. Right? You don't get to add an asymptote to a graph that doesn't have one just because we only look at that up to x equals 1. All right, so then I need to go figure out some of my points. Now I know I translate this 4 means I'm going to have a what? Vertical stretch, which could also be a what? Horizontal stretch, but we do them one at a time. So I start with an anchor point, which is right here, but that's not because that's why the point's there. But my anchor point would be 1, 1. So I'm going to do a vertical stretch by a factor of 4. My y value is 1. Multiply that by 4. That changes the y value to 4. And then I translate to the left 3 and end up with that point right there. Okay. Then I'm going to start back at my anchor point. This time I do a horizontal stretch of 4. So my x value is 1. Multiply that by 4. It's now 4. Then I translate to the left 3. And oh, look, I end up at that point. That point was actually that point. You just didn't necessarily know that to begin with. It could have been an additional point. Then my other anchor point is -1, -1. Do a vertical stretch by a factor of 4. So my y value becomes -4. Then I translate to the left 3. Go back to -1, -1. Do a horizontal stretch by a factor of 4. So my x value becomes -4. And then translate to the left 3. Now, once you get one set of points that you're confident with, there's symmetry here, so you can figure these out without actually doing that counting if you understand the symmetry of the graph. That is okay, that's legal. So when we go to draw that in, these points are enough for us to get the shape with our asymptotes, so something like that. And then when we go to draw this one, as we come down through here, and it stops right there. It's a closed circle, and that's as far as that graph gets to go, right? Okay, so then I move on to the second part. The second part, what's the parent function there? Linear. My y-intercept is -7. I don't care, right? This is a point on the line somewhere. And then your slope is what? 2. So from here, I just go up 2 over 1. That gets me my other point. And I'm sorry, what? Everybody okay with that? Any questions? Okay. Alrighty. Then domain. Is it all real numbers? No. We go from -infinity to what? -3, and then -3 to infinity. So that asymptote is still holding me up there. Does my range have to go from -infinity to 0? No, I don't have to stop on the range because, yes, I have an asymptote here, and y equals 0 is not a value here, but it is here, right? So that's fine. So that one gets taken care of. Let's go from -infinity to infinity. How many discontinuities do I have? 2. The first one is called what? Infinite. So I have infinite discontinuity. Infinite, oh, if I could spell it right. Infinite discontinuity. Where? X equals -3. And then jump where? X equals 1. Okay. Everybody okay with all that? Yes? Okay, good deal. Alrighty. 6. I got 3 pieces. So this -4 gives me 3 times the -4. That's -12 plus 8, which would give me what? -4. So go to -4, -4, and that's a closed circle. Then at -4 when I go to this one. I got -4, and then what would the y value be? -1, and that's an open circle. All right, y'all see if you can get the rest of those on there real quick. Okay, so when I get this endpoint, I'm also going to grab this one. So at 2, I'm also at -1, and it's closed, right? And then I'm going to find this other endpoint here. So this, when I substitute 2 in, 2 minus 2 is 0. And then -5 would be -5. So at 2, 1, 2, 3, 4, 5, open or closed? Open. Okay. It makes the most sense to me to go find all those points before I do anything. We'll do the last one a little bit different. If you want to find them as you go, that's fine, but sometimes that causes you to draw too much, so you want to be careful. Because we have 3 sections, so that means I have this ends the first one and starts the second one. Oh, I'm sorry. This ends the first one, this starts the second one, ends the second one, starts the third one. There's 3 sections. What did I say? Oh, it says that is what I said? Okay. I was like, oh, I thought you were correcting me. That's why I was like, what did I say? There's 3 pieces to it. It might make more sense as we go through it. But look, what you're doing when you're finding these is you're using the endpoints of these domains. Yeah, because I got to end the first one, start the second one, and end the second one, and then start the third one. Okay. So with the first section, this is what type of parent function? Linear. So this is the point that I have, right? Linear. And then the slope is what? 3. Okay, so that's pretty easy to get on there. Now, I can't go up 3 and over 1. Can I do that and put a point there? No. Okay, but I can go down 3 and to the left 1. Got to be able to graph lines very easily. Old business. Okay. Then, oops, I don't know where this extra stuff came from there. Then this just represents what? Does it represent a point?
No, it's x equals. No, it's y equals.
It's y equals. This is basically y equals. This is y equals -1. And a y equals line is what? Horizontal. So it's just a horizontal line right there. That's it. Then this part is what? A quadratic. So I'm going to have a parabola. I have no idea what part of the parabola I'm going to have at this point. I have no stretches or compressions. I have no reflections. It's just translations. So if I start here at 0, 0, where my vertex is, I'm going to go to the right 2 and down 5, right? Oh, that is my vertex, right? So since that is my vertex, that tells me I'm only going to have half of it. So then I can go to 1, 1, and I'm going to go to the right 2 and down 5 and make my point. Then I can go to 2, 4, and I'm going to go to the right 2 and down 5. And then that gets me what I need to get my parabola in there, like so. Everybody good? Alrighty, is my domain all real numbers? Yes, it is. So infinity to infinity. Is my range all real numbers? Yes, infinity to infinity. How many discontinuities do I have? 2. Both of them are what kind? Jump. So I have jump discontinuity at x equals -4 and x equals 2. Okay. Everybody okay with all that? All right, good deal. Let's go to the last one. So we've got f of x equals 7 if x is less than -1. So when x is -1, I can go to 7, but I have to have a what there? An open circle. Okay. This just represents a horizontal line. So I'm going to go ahead and draw in that horizontal line. We'll find the endpoints as we go this time. Then I'm going to plug in this endpoint of the domain. So -1 cubed is -1, minus 1 is -2. So -1, -2 is a closed circle. I'm going to put the other endpoint in. So 2 cubed is 8, minus 1 is 7. So I'm going to go to 2, 7. And those are the 2 endpoints of that middle section. I know that that parent function is what? A cubic. So I should have in my mind what that shape looks like, right? So I'm going to start at 0, 0. That's my point of inflection. I have no stretches or compressions, no reflections. All that happens is that it goes down 1, right? So there's 1. That's my point of inflection. 1, 1 is an anchor point. All that happens is I shift down 1. -1, -1 is an anchor point. When I shift it down, well, that was the point I had, right? 2, 8 is also an anchor point, and when you shift down, there's that point too. So you just have to, when you go to draw these, especially when they've been stretched, and this one hasn't, but you just have to really make that honest effort to make it look like there's a change in direction so that it doesn't look like a line segment right there, and it would look something like that. I'm not happy with that. I don't know if that's any better, but okay. We tried, I know. All right, so when x is greater than 2, I substitute this 2 in here. That means I'm square root of 4, so that'd be a -2 plus 1, which is -1. So 2, -1, I'm going to open circle there. So what kind of function is this? Square root. That negative is going to reflect it in what? The x-axis. That 2 does what? Horizontal compression of 1/2, and then that 1 up 1. Okay, so I'm going to start with this 0, 0 as my anchor point. I reflect it, nothing. I compress it, nothing. I just move it up 1. Can I put a point there? No, that's not even in my domain. So my next one was 1, 1. Well, I reflect it in the x-axis. I horizontally compress it, which means I multiply the x times 1/2, and then I move it up 1. Still can't use that, right? So then I have 4, 2, right? 1, 2, 3, 4, 2. So then I'm going to reflect that in the x-axis. It ends up right here. I compress it by 1/2, and then I shift it up 1. Well, that is that point, right? And like now I'm out. But I'm out of the anchor points. I could substitute in a lot of other things, but you want to substitute in what's going to make sense and what can help you, right? Substituting in a 3 gives me a square root of 6. Do you know what that is? No, you don't, okay? So what could I substitute in that could give me something? You're on the right track. If I wanted the square root of 9, what would I substitute in? 4.5. So if I go to 4.5, 1, 2, 3, 4.5. So I substitute in that 4.5. That gave me the square root of 9. Which is 3. -3 plus 1 is what? -2. So at 4.5, I'm at -2. Well, I could get, that just gives me 2 points. Can I substitute in something else that might help? What's the next square after 9? 16. So if x is 8, then I can, so here's my x of 8. I substitute in 8. 2 times 8 is 16. Square root of 16 is 4. -4 plus 1 is -3. So I get this point right here. You know what the square root graph looks like, right? And it's been reflected, so the curve is just coming this way now. Like so. It doesn't look very curvy, but you get the idea. I can do better on a piece of paper. So in that case, we had to substitute in some numbers so we'd have something to do, but for the most part, you're not making a bunch of table of values because you don't always know which pieces to get in there anyway. Or if you're just substituting them in there because it's the x value, you get a funky y value that's not going to help you. All right, so our domain, what's the domain here? -infinity to positive infinity. Is that the same for the range? No. We go from -infinity to what? 7. Do I include 7? Yes, I do. Discontinuities are jump, and that's at x equals what? -1, and x equals 2. Okay. Everybody okay with all that? Any questions? All right, so the graphing is the same idea as what we've been doing, right? You just add the idea that it's a piecewise in there.